So welcome to today's class, that is on fine aggregate. So today in fine aggregate we will discuss regarding sieve analysis of fine aggregate. Okay, so in order to carry out this sieve analysis we require certain apparatus. First among them is the IS sieve. Okay, so with IS sieve we also require weighing balance. First one is your IS sieve. We require weighing balance. Then a tray for easy handling of your soil sample, scoop and pan. And then at the end we require sample of fine aggregate. Now let us discuss what is this IS sieve. So before as we know as we have discussed in the previous class, the aggregate which is in the range of 4.75 to 4.75 mm to 75 micron is termed as fine aggregate, right? And the aggregate which is greater than 4.75 is termed as coarse aggregate. Okay, so in this class what we are going to discuss, we are going to discuss about the soil sample which is concerned with this category, that is fine aggregate, having a range of 4.75 mm to 75 micron. Okay, so this is the IS sieve setup we have to use. Now what is this IS sieve? Each and every sieve has got this mesh inside with the opening of different standards. For example, we have to have, for this particular procedure of sieve analysis, according to the IS standard, we require the IS sieve of 10 mm followed by 4.75 mm sieve, then 2.36 mm, 2.36 mm followed by 1.18 mm, then after that 600 micron, 300 micron, 150 micron, 75 micron. Then at the end we require residual tray at the bottom. And also this setup has to be closed with a lid. So that soil sample does not oozes out of it. Okay, so this is what the IS sieve basically comprises of, and the arrangement should be in this manner, that is 10 mm, 4.75 mm, 2.36 mm, 1.18 mm, 600 micron, 300 micron, 150 micron, 75 micron, and then at the end we require a residual tray to collect the sample which passes through 75 micron as well. Okay, now after arranging these sieves, what we will do, we require the observation sheet to collect the data, to record the data. So what is basically done here, what we do is we take a known quantity of soil sample, for example 1000 gram or 1 kg, 1000 gram or 1 kg, that is okay, 1000 gram is nothing but 1 kg. So what we do is we take a known quantity of soil sample. That known quantity of soil sample with the help of weighing balance is taken, and then it is poured into the topmost IS sieve. After pouring the soil sample into the 10 mm sieve, what we do is we close the lid. Okay, and then after the closing, what we do is we subject this IS sieve to shaking, okay, by the help of automatic sieve shaker or by manually we have to shake this entire setup. Okay, either automatic sieve shaker, by using automatic sieve shaker, or by manually we have to shake this entire setup so that the soil particle should pass through one another. Okay, so after doing that, what we get is we get soil sample in their respective trace, okay. So that data has to be recorded in a observation table. For example, so this is the format of your observation table. Now what we have done in the first step is we have to take what is the weight of aggregate used for sieving purpose. That is nothing but 1000 grams. Okay, now I have already recorded the data and we will discuss with this data. Okay, so as we know, we have taken this IS sieve sizes 10 mm, 4.75 mm, 2.36 mm, 1.18 mm, 600 micron, 300 micron, 150 micron, 75 micron, and then at the end we have got a residual pan. So this is the weight retained on each of these IS sieves. Okay, I am just assuming these numbers from the previous data we have. Okay, so in 10 mm, as we know, we are taking the fine aggregate soil sample, so we will not we did not have anything in 10 mm IS sieve. Okay, now in 4.75 mm we have retained a weight of 15 grams. In 2.36 mm we have retained a weight of 25 grams. In 1.18 mm sieve we have retained a weight of 325 grams, and then in 600 micron we have retained a weight of 205 grams, and in 300 micron we have retained a weight of 2.82 grams. In 150 micron we have retained a weight of 105 grams. In 75 micron we have retained a weight of 21 gram. In the residual pan we have retained a weight of 22 gram. Okay, so this is what we have calculated. By the help of weighing balance, we have recorded all the data which we have collected in different IS sieves. Now after doing that, what we have to calculate is percentage weight retained, that is, which is nothing but we have to calculate what is the percentage of this one. Okay, so what is the procedure for that? For example, for 4.75 mm IS sieve we have retained a weight of 15 gram. Okay, so I will take that 15 grams here. I will take that 15 grams divided by what is the quantity of soil sample we have collected is 1000 grams. The total quantity of soil sample is 1000 gram. Just what we have to do is we have to multiply it by 100. Okay, so this is nothing but 1.5 gram. Okay, so percentage weight retained here is 1.5. So similarly for 25 we have obtained a value of 2.5. For 325 we will get the value of 32.5. Okay, so let me just take another example. 325 divided by 1000, which is nothing but the total quantity of soil sample we have collected, we have used for this particular experiment, and then we have to multiply it by 100. So if we go through the calculation, it will be around 32.5. So similarly all the values have been written over here. Now after writing percentage weight retained, what we have to do is we have to calculate the cumulative weight retained. Okay, so it's a very simple procedure here. So first is 0 0. This is the amount of soil sample we have obtained. So we have not obtained anything on 10 mm IS sieve. Okay, in 4.75 mm we have obtained 1.5. So I'll directly write this 1.5 here. Okay, in 2.36 mm what you have to do is, so you have to add these two values, 2.5 plus 1.5. Okay, so if I add 2.5 plus 1.5 we will get a value of 4.0. Okay, that is nothing but cumulative weight retained on 2.36 mm up to 2.36 mm is 4. Okay, so in 1.18 what we have to do is, again we have to add these two values here. 4 plus 32.5 will get us 36.5. Similarly, if we keep on adding this value, then these are the results that we are going to obtain. Okay, so as you have we have here, in 600 micron the cumulative weight retained is 57. In 300 micron cumulative weight retained is 85.2. In 150 micron we have retained around 95.7. In 75 micron we have retained 97.8. and in the residue we have written. So if we add all this, the value will be 100. Okay. So now percentage weight passing, what we have to do here, here is we have to subtract this value from 100. For example 100 minus 1.5 will give us 98.5. Okay. Similarly 100 minus 4.0 will give us 96.0. 100 minus 36.5 is 63.5. 100 minus 57 is 43. 100 minus 85.2 is 14.8. 100 minus 95.7 is 4.3. 100 minus 97.8 is 2.2. 100 minus 100 is 0. So this is how the IS sieve, the sieve analysis is carried out. Okay. Now, what after obtaining this value, after obtaining percentage weight passing, what we can do is we can distinguish in which zone the soil sample comes in. Okay. So from IS 456, so this is let me just check it. From IS 383 1970, what we can do, we have got this tabular different zoning zones, that is grading zone 1, grading zone 2, grading zone 3 and grading zone 4. Now what you have to do is the percentage weight passing we have to compare with these zones. So whichever the zone matches, the soil sample will be in that particular zone. For example, let us say this values match with zone 2, then the soil can be considered as zone 2 soil. If it matches with zone 3, it has to be termed as zone 3, like this. So this is IS 383.